Hi guys, welcome back. So right now we're going to look at something else, right? Remember I said our leading question was, why is a to the exponent of 2 called a squared? That's what we're going to try and look at in this particular segment of the show. Now, remember the question that I started with, right? A to the exponent of 2, why is it called a squared? Now we're going to use what we call a quadrilateral to try and show you what exactly this is all about. So what I have here is a square, right? You know a square will be a quad with 4 equal sides, and then the adjacent sides are perpendicular to each other. Hence, I showed you the 90-degree angles there, right? So what I have with this is, you know that the area of a square is given by a multiplied by a. Or rather, because this falls under rectangles, we can say it's length multiplied by breadth. But because the length and the breadth are all equal, we just say length multiplied by length. Hence, it becomes a multiplied by a, which then gives me a to the exponent of 2, right? This is a big idea. This is where the a squared, why? Because of the concept of a square, that we are taking a and we are squaring it. That's what we are trying to do here as the big idea. But now, what happens now if the area has a side length of a plus b? So it's no longer now just a, right? As I had with this one. If I add a portion to this particular square of mine and then I make it a plus b each side, how will I then find the area and what will that give me? So the shape will look something like this, right? So on the side here I will add my length, which is the b there, and you know this is still a here, it does not change anything, and that is the b there. This will be b because of this one here. So it means I have a rectangle here which has a and b, and I have a new square there by the corner which is a square b by b. Now, to try and talk about this, if I want you to find the area of this, right, I'm firstly going to label them. I will label this 1 so that you see where we are going, right? And then I will label this 2. I will label this one here 3. I can't really write on it because then you won't see what I'm going to write. And then here I will label it 4. Now, if I want the area of this whole thing, it means that it needs to be a plus b multiplied by a plus b, right? But what does that give us? Remember that shape 1 is a square, shape 2 is a rectangle, shape 3 is a square, and shape 4 will be a rectangle. So shape 1, for area 1, it will be equals to a squared. You remember that from the previous example we did. And area 2 will be equals to a multiplied by b. And for area 3, which is another square, will be equals to now b squared. And for area 4, it is a rectangle, so it will be b multiplied by a, right? So what does this tell us? This tells us that if we want to find the area of the whole shape, we must add area 1, 2, 3, and 4. That will give me a squared plus ab plus b squared plus ba. But you remember you need to group the like terms. So the ab and the ba are like terms. If you add them, they will give you 2ab in the middle, and then I'll have b squared there, and then I'll have a squared here. Now, the beauty of what I've just done is what we call trying to square a binomial, right? To square a binomial, what that simply means, you are multiplying that binomial by itself. Remember, I said when we started, it's a plus b multiplied by a plus b. So that means it's a plus b all squared. And to multiply that, remember, you still use the distributive law. the a is multiplied by that a, and the a is multiplied by the b, which gives me a squared and ab. And then the b is multiplied by that a, and the b is multiplied by the b there, which gives me ba and b squared. So if you add your like terms in the middle, it then gives me 2ab. This is really the beauty of mathematics, guys. This is what shows you where the a plus b all squared comes from, and what does it give you if you were to square a binomial. Because remember, we've been trying to square a monomial all the time, but if I square a binomial, what does then that become? But now, this is just a long way of doing this, right? To have to multiply each term with every term in the other bracket. So we then find a way that is short, because remember, we are very smart people, mathematicians. I mean, we know what we are doing. So we use what we call FOIL, right? And the FOIL will be first, which is the F, and then the O will be the outers, the I will be the inners, and the L will be the last. Now, in practicality, this is what I mean. The first will be the first terms in both the brackets, and then it will be the O, which is the outers. So it is the outer terms of the brackets, this one and that one. And then the inners will be the inner terms of each bracket. And then it will be the last, meaning the last term in each bracket multiplied together. So if I multiply the first, it will give me AC. I multiply the outers, it will give me plus AD. I multiply the inners, it will give me plus BC. I multiply the last, it will give me plus BD, right? This is the same as if you were to use the distributive property as we've been trying to look at it. So if I use the distributive property, I would write A open bracket C plus D, right? And then this must be plus B open bracket C plus D, right? So this gives you roughly the very same answer. Not even roughly, it will give you exactly the same answer as what I have. Because the A multiplied by C will give me AC. The A multiplied by D will give me AD. The B multiplied by C will be BC. And the B multiplied by D will then be BD. And that's what this is all about. So this will be the easier method of how to try and multiply two binomials. Now let's look at a typical example of what this means. If I have 3y minus 1 multiplied by 2y plus 4, two ways. You can use FOIL, you will get the same answer. You can use the distributive property, it will give you the same answer as what you did when you use FOIL. So I'm going to use both of them just so that you can see what I'm talking about. So the first method will be me using FOIL, right? If I use FOIL, it will be the first, which is 3y times 2y, that gives me 6y squared. And then it will be the outers, which are those ones there. It will give me plus 12y. And then it will be the inners, which are these ones here. It will give me minus 2y. And then it will be the last, which is the minus 1 and the 4, which will give me minus 4. And if you simplify this, it will then give me 6y squared. The 12y minus the 2y will give me plus 10y, then minus 4. And that will then be my answer. That's the first method. If we use the very first thing that we did in this lesson, which is the distributive property, I would then say 3y open bracket, 2y plus 4, and then minus, remember I said we maintain each sign that we have, 2y plus the 4, right? And then you use your multiplication or your distributive property, which then it becomes 6y squared plus the 12y minus 2y minus 4. And then 6y squared will remain as 6y squared. There's really nothing I can do to it. Plus 10y minus 4. And that's what you then need to make sure that you do understand on how to actually do. So you can see that, excuse me, both my answers are the same thing, irrespective of the method that you use. But now I know that you guys will take the method that works best for you. That's very correct. And that's very okay, right? As long as you do understand what you are trying to do. And what you are trying to do will be to multiply each and every term that is in one bracket with every other term that is in the other bracket, I mean. And that's the goal here. How you do that, it's really up to you, but only if you are not violating any mathematical laws, because I know you guys like concocting things, but from now on, I know you're going to do the right thing. So just make sure that when you're multiplying, you are multiplying correctly, either using FOIL or using the distributive property as we just did now. Now, one more example that I just want us to quickly look at that has to do with this will then be if I multiply two terms, right, such that the middle term vanishes, meaning I no longer have the middle term. What does that mean? So this is something that I'm just going to introduce now because at a later stage you're going to talk about it. So if, for example, I give you 2y minus 1 in this bracket, and here I give you 2y plus 1, right? How will I then work that out? So let me just erase this because I know that you've already written it down so that I can show you this one here. If I work out this one, I'm just going to use FOIL, right? But you can use either or. 2y multiplied by 2y will give me 4y squared. And the 2y multiplied by the 1 there will be plus 2y, and then minus 1 multiplied by the 2y will give me minus 2y, and then minus 1 multiplied by 1, it will then be minus 1, and that's what I will then have there. Remember, you work out your like terms after doing that, so it will be 4y squared. The 2y minus 2y is going to be 0, so this will all be minus 1, and that will be the final answer that we have. And there isn't really much that you can do from here. So at times when you're multiplying two binomials, you're going to get three terms. We know we're going to call this something at a later stage. Or you can multiply two binomials. Instead of getting three terms, you then get two terms that we have, and you can see they are subtracting each other, but also we're going to give this a name at a later stage. That's it from me, guys. I hope you've been having a blast and you are still going to have some more blast after the ad break. Let's just quickly take an ad break just to freshen up our brains and come back to do some more work. Stay tuned.